Welcome to section 9.2, ellipses. This is the second conic that we will be looking at. An ellipse is a set of all points in a plane whose the sum whose distance from two distinct fixed points called the foci is constant. So just to kind of show you what that looks like, if you kind of run through the construction of how an ellipse is created, you have the center, and you set its width to half the ellipse width, so you can see kind of how that's done. Then you're going to create the move the compass to the end of the minor axis, draw two arcs on the major axis, so that distance between those 2 points are the same. That represents your foci. Foci is plural for focus, so there's two of them. And then what you're going to do is you're going to tie a taut string between pins at the left and right side of the ellipse. And then from that, you're going to pull the string taut with the pencil. And as you do that, that distance is going to be exactly the same, drawing a large arc all the way around the figure. And so once again, that distance that you see right there as the string is taut, that distance stays the same all the way around the ellipse. And so that's how an ellipse is actually created, and that's what that definition for ellipse represents. We have two different types. We have a horizontal and a vertical. So you can see on the horizontal ellipse that you have your center, you have your major vertices, your minor vertices, and then once again two foci. So once again, foci is plural for focus. And so if you look at this, I'm going to mark a couple things in here. There's some values that we need to know. And so from the center to the minor vertices, that is a distance of b. From the center to the major vertices, we're going to represent that distance as a. And then from the center to each of the foci has a distance of c. So part of those values come from the equation. Other parts we have to find by using different equations. Vertical works the same way. The major to the center is a. The center to the minor is b, and the center to the focus is c. So it doesn't matter if it's horizontal or vertical, those distances represent the same. You can see that the major vertices are the farthest one away from the center, and the focus of the foci will always be inside of the ellipse. Your two equations, you have x minus h squared plus y minus k squared, very similar to a circle. Now a circle has a radius, so it's the same all the way around. With an ellipse, you have two distances. You have a major and a minor. Your a is always the largest number in the denominator, which makes sense because your a value represents the distance from the center to the major, which is the largest distance. So that number is always going to be the largest. So you have your a squared and your b squared, and this is always going to be equal to 1. Okay. And these values on the bottom, the a squared is underneath, so this is x, the a squared is underneath the x. So if you think about this, and I'll kind of show you this in class as well, if you think of your x-axis, so here's your x-axis, and it is underneath, the denominator is the a squared, so that represents a horizontal line, so therefore it's a horizontal ellipse. If you look at the second one, which is vertical, and you look at where your a value is, now your a value is underneath the y. So we think y-axis, and therefore we think vertical ellipse. So you're going to have to kind of pick some things as to how to remember some of this stuff as you go through and do it. But the a value is always the largest, and the ellipse is always equal to 1, where a circle is equal to the radius squared. So the differences and similarities between an ellipse and a circle. Some of the things that we need to know. The major axis contains the center and foci, and we also could add on to that, it also includes the major vertices. So oops, I can't fix that. Oh well, I'll write it in. So this right here contains the center, the foci, and the major vertices. And the minor axis is perpendicular to the major axis. It contains the center and the minor vertices. The center is HK, just like the circle. C, as we talked about, is the distance from the center to the foci. Ways to remember, students have told me this. C has foci in it, or foci has the letter C in it, so that the distance is the same. B is the distance from the center to the minor vertices, and A is the distance from the center to the major vertices. Once again, major has the letter A in it, so just ways that students have remembered the difference between these. 2B is the length of the minor axis, and 2A is the length of the major axis. It's twice that, because remember, going back to the picture, the A value is only distance from the center to the major, so if you include the entire axis, it's twice that. And then we have this relationship on the bottom here where A squared minus B squared is equal to C squared. This should look very similar to Pythagorean theorem, and it actually is, but it's written for C squared because in the equation we don't have the C squared. Alright, we only have A squared and B squared. So the relationship is for the C value, how to find it. But if you look at this, just to kind of show you, if we added B squared to both sides, we would have A squared is equal to B squared plus C squared, which is Pythagorean theorem, but the A value would actually represent the hypotenuse in this problem. So those are the different things that we need to know. The other day, talking about circles, we talked about the 3 different things that we were going to be doing on each of these problems. We're going to graph, we're going to write the equation, and then we're going to work backwards, and that's what we're going to do on this one as well. So let's start with the graphing part of it. So I'm going to give you the correct equation. I want you to go through and identify all the important aspects of it and then graph it. So kind of the first thing is it horizontal or vertical? Well, the A squared is the largest, so that's 9. That's got to be the largest distance. It's underneath the x squared, so we think, alright, x squared, x-axis, going this way. So therefore, we have a horizontal ellipse. We know A squared is the largest, which is 9. B squared is the other one, the smaller one, which is 4. And then that relationship, remember, C squared is equal to A squared minus B squared. So 9 minus 4 is 5. Take the square root of each of those. And we have square root of 9 is 3, square root of 4 is 2, and then the square root of 5 is square root of 5. The center is HK, so that would be at negative 3, comma 1. Foci, this has to do with your C value, major has to do with A, and minor has to do with B. So we can figure these out before we graph or after we graph, however you want to do it. But once again, we're thinking in terms of our main points. All our main points are horizontal, so if we're moving left and right, what is changing? The x. Major vertices, moving left and right, it's horizontal. What is changing? The x. Minor vertices perpendicular, so we're going vertical, so what's changing? The y. And if you just picture that and think of that, then you know which value is actually changing. So for the foci, the square root of 5, we're going to be adding that to the x value. So we would say negative 3, and we'll actually be adding it and subtracting it. So negative 3 minus the square root of 5, comma 1, that's 1 point. And then you also have negative 3 plus the square root of 5, comma 1. So the y value is not changing, only the x. With the major, once again the x is changing, and you're adding 3 to your center. So negative 3, and you're subtracting 3, so I'll do the minus first. Negative 3 minus 3, comma 1. Okay, let me get rid of this up here. And that simplifies to negative 6, 1. And then you'll also do negative 3 plus 3, comma 1, and that's at 0, comma 1 as well. So those would be your 2 major vertices. Your minor is B. We're going perpendicular, so the y value is going to change. So the negative 3 will stay the same, and you'll do 1 minus the B value, which is 2. and so that's equivalent to negative 3 comma negative 1, and then negative 3 comma 1 plus 2, and that's at negative 3 comma 3. And so you don't necessarily need the first part, you can just add them or subtract them in your head, but they do need to be simplified. And so what we have now is we have all the important parts of it. Now we can go ahead and graph it. So at negative 3, 1, there's the center. The other thing we can do is we can just count, because the foci, when we go to do the foci, the square root of 5 is approximately 2 point something. Okay, whatever that something is doesn't really matter. We're just going to count 2 units to the left, 2 point something, so get in between those two values, and 2 something to the right. And so that represents the foci. The major, that A value was equal to 3. So we can count 3 units to the left, really close on this one to the foci, 3 units to the right, and that point should be at negative 6 comma 1 and what looks to be 0, 1, and that looks correct. And then your minor has a distance of 2, so you count 2 up and 2 down, too far, and there's your minor vertices. And so we'll go ahead and graph. Well, it shouldn't be filled in, but I don't know if I can fix that on this. Let's see, fill color, none. Alright, so let's try again. There we go. And so there's our ellipse. And so, I can delete that, but so anyways, that's the information going through there and then actually graphing it. So, alright, so that's the first aspect, is being able to graph. The second one is being able to write the equation. So just like we did with a circle, we're going to do the same thing. We're going to write the equation, and then really we're going to stop there. We can do the graphing if we need to, but the focus on this one is really just writing the equation. So with a circle, we got everything together. We had to complete the square. Now with an ellipse, we're going to run into a small problem, is that the numbers in front to complete the square are not going to be the same anymore. So we can't divide everything through by 4, because then it's going to create fractions in front of the y squared, and then we won't be able to complete the square. So we're going to do it a little different. We're not going to divide, we're actually going to factor it out. So we'll take a 4 out, but we're only going to factor it out of what we need, which is only the x terms. We don't have to factor it out of everything. And then the y squared we would factor out, but we don't have anything to factor out, so that one's okay. And then we'll add the 3 to the other side. And then now we'll complete the square here. So very similar to a circle, we just don't divide, we're going to factor it out. Now we can complete the square. You're going to take half your middle term and square it. So half of negative 1 squared is 1. So you add 1 here. Now the mistake would be to say, okay, well, if we're going to add 1 there, then I'm going to add 1 to this side. The problem is you really didn't add 1. You added, change the colors for you. You actually added, remember this was 4x squared minus 8x, so you added a 1 to complete the square, but you really added 4 to that side of the problem. So you need to add 4 to the other side. You'll complete the square on the next one. Half of 6 is 3. Square the 3, and you get 9. Now this one, you didn't have to factor anything out, so we really did truly add 9 to that side. And so our equation so far is 4 times, factor the x squared minus 2x plus 1, so that's x minus 1 squared, let me fix that, plus y plus 3 squared, and then add up the 3, 4, and 9, and that will give you 7 and 9 is 16. Now this looks similar to a circle, With an ellipse, because those coefficients are different in front of your squared terms, this 16 needs to be a 1. So how do we make this 16 a 1? We divide by 16. And you simplify that. So 4/16, this reduces to 1/4. This one can't reduce, and then this one will reduce to 1. So your equation, when you're all said and done, will be x minus 1 squared over 4 plus y plus 3 squared over 16 is equal to 1. And that's really where I would stop you normally. You can kind of do the next part. Really, it's just going back and solving everything and doing the center. And I'll do part of it. If you have additional questions in class, let me know. But so the center on this one would be 1 comma negative 3. Your a squared is the largest, which is 16. B squared is 4. You subtract, because a will always be the largest, so that would give you 12. Take the square root. The square root of 12 reduces to 2 square roots of 3. And then to find the foci and everything, remember this is vertical because of where the a squared is. The a squared is the largest, it's underneath the y, so it's up and down, which is vertical. So your foci is 2 square roots of 3. Your major is the a value, which is 4. The minor is the b value, and that's 2. So you're changing on this one, the foci, you're changing the y value, so it'd be 1 comma negative 3 minus 2 square roots of 3, and 1 comma negative 3 plus 2 square roots of 3. The major, you're going to add the 4 and add the 4 to the 1 and subtract it. So 1 minus 4 is negative 3, and then 1 plus 4 is 5. But I messed up because we're supposed to, whoops, let's just fix all of this. We're supposed to be changing the y value. I actually changed the x value, so I'm going to change the y value. So negative 3 minus 4 would be negative 7, and negative 3 plus 4 would be 1. So that would be the correct ordered pairs. And then for the minor, it's perpendicular, so now the x values are changing. And so 1 minus 2 would be negative 1, and 1 plus 2 is 3. So the y value doesn't change, that the x values do. So your center is at 1, negative 3. Your major is at 1, negative 7. So we should be counting 4 units this way and 4 units up, so at 1, 1. So these are your major vertices. This is your center. Your foci is 2 squared root of 3 away. Well, that is approximately, the square root of 12 is approximately 3 point something. So we again count 1, 2, 3 something, very close to the vertices on this one. And then your minor, you're only counting 2 away. So this should be at 3, negative 3, which is what I have. And 1, 2, which would be at negative 1, negative 3, which is what I have as well. So on the graph, you're doing more counting than anything. But by counting, you're adding and subtracting to your x and y value. Alright, so let's go ahead and kind of hit on this last question here. The last question is you're going to work backwards. So I have a graph on here just to help you identify the important parts and to graph them. So write an equation of an ellipse with a foci of negative 2, 1. So at negative 2, 1 we have a foci. And we also have one at negative 2, negative 7. And the major axis has a length of 10. So what do we need for an ellipse? Well, we need to know if it's horizontal or vertical. We need to know the center. At HK, we need a squared and we need b squared. Those are the things that are going to identify the points or the values that we need to write in the equation. So horizontal or vertical. So right now, look at this. Your major axis has a length of 10. Your foci are going up and down, which means your y value is changing. So if your y value is changing, then this is going to be vertical. Alright. We also know the center falls in between these two values. So if you're going from 1 to negative 7, what's that midpoint? You can add them up and divide by 2, and that will tell you what it is. So to find that midpoint, to find that center, it's going to be at -2 comma, and if you add them up, it'll be -6 divided by 2, which is at -3. And if you plot that, you'll see it's 4 away on both sides. So you actually know this distance as 4. Now it doesn't ask for it, but let's go ahead and write it down. It might be something we need. So we know the C value has a distance of 4, that's the foci. Your major axis has a length of 10. Well, the major axis is twice that A value, so that means the A value is 5. So if we wanted to, we could go 5 and 5. That represents the major vertices. But right now we have a couple of things. We know it's vertical, we know the center, and we know A is 5, so we actually know that A squared is 25. So we have 3 of the 4 things that we looked for. We don't have the B squared. It says nothing about minor vertices. So how are you going to find the minor vertices? Well, you do know C, which means you know C squared is 16. Even though that's not part of the equation, we have the relationship that A squared is equivalent to, we have C squared is equivalent to A squared minus B squared. So this is normally what we're trying to find, but now we have C squared, we know it's 16, A squared is 25 minus B squared. So what is B squared going to equal? 9. 25 minus 9 is 16. So now we actually do have the 4th piece of information, and so now we can actually write the equation given this. If it's vertical, we know, first off, the center is x minus -2, so that's x plus 2 squared, plus, and I'll get to the denominator in just a second, y minus -3, so that's y plus 3, squared. And we know it's equal to 1. Now where does the A and B go? Well, because it's vertical, the A squared has to go under the change of y, so we want the 25 underneath the y squared and the 9 underneath the B squared. So there is your equation that is working backwards with the information. Now there's a lot of different questions in your homework dealing with this idea, so make sure you practice on all of those. And that's going to be it for now. I do have this slide that talks about eccentricity, and this is something we can kind of talk about in class a little bit. The big thing in terms of doing your homework is to find the eccentricity. It'll ask some questions about it, but to find the eccentricity, which has to do with focal distance to vertex distance, is to take the C value and divide by the A value. But like I said, that's something we can talk a little bit more about in class. So here's your homework, and the next one we will look at will be hyperbolas.